When you want to use your calculator to figure out what your x or theta values are in a problem, like in this one, for example, there are going to be several steps that you want to take. The more that you do it, the easier it'll get. So let's go ahead and try one together. Notice that in this problem, we have an interval at negative pi to positive pi. So that's going to be important for how you set up your window in your calculator. Now, just to make this a little bit easier, I already have an equation that is completely isolated on the left with some value on the right. Some of your problems may not look like this in the beginning, so just make sure you do all the algebra to get whatever your trig function is completely isolated. So let's go ahead and go to the calculator and start our process here. So the first thing I want to do is check the mode. All right, whenever you graph on a calculator with a trig function, your mode has to be radians. All right, so my calculator is in radians. If yours is in degrees, make sure you hover over radians and click enter. Okay, now once you do that, you want to go ahead and open up the window. So the window button is right next to y equals. So hit window, and your min and max are going to be where you set your interval. So in our problem, our interval was negative pi to positive pi. So the negative has to be your min, it's the smaller value, and then the other one will be your max. So for x min, I'm going to go ahead and do negative pi. And when you press enter, you'll see that it turns into a decimal value. Let it do that. And then for max, I'm going to do second positive pi, press enter. Now for your x scale, don't worry about that. For your y min and max, remember that we are kind of investigating what's going on at the x-axis. So vertically, you don't want a window that's really huge, like from negative 100 to positive 100. You want something pretty close to 0. So for that reason, I have negative 3 to positive 3, but you could also have negative 10 to positive 10 or negative 5 to positive 5. Anything close to 0 works out fine. The rest over here, all these other options, if you're seeing them in your calculator as well, they're really not too important. Okay, now we've done the mode, we've done the window. Next, let's go ahead and plug in our equation. So hit the y equals button. If you have anything written there, clear it out. All right, and we have, let's take a look at our problem. We have cosine of theta equals negative 0.81. Now, when we plug something into the calculator, our equations always have to equal 0. So all I need to do is get this number over to the left side by adding 0.81. So it's going to say cosine of theta plus 0.81 equals 0. All right, so that's what we are going to plug into the calculator. So make sure it's always set equal to 0. So cosine of theta, or x, plus 0.81. Let me just double check that that's the correct decimal. Yes. All right. Now that we have that, we're going to go ahead and hit the graph button. And there we are. I see 2 points of intersection. The first one is right here, and the second one is right here. All right, so let's go ahead and start calculating what those points are. So let's go to second trace. All right, I do second trace because I'm actually trying to get the calculate button, so you'll see that behind in blue. Now in the calculate menu, we want to figure out what the zeros are. So we're going to choose option number 2, press enter, and the calculator starts giving us instructions. It's going to ask us what is the left bound for the very first point that you want to find. So the very first point that I want to find, I'm going to use the left arrow. All right, the actual point is right about here, but I need to go to the left of that point. All right, I need to set a boundary. So I'm going to go over to the left a few times. That looks about good, and press enter. And then the calculator tells me, give me a right bound. So I'm going to go to the right of that point, but not so far right that I am including both of the x values. Okay, so this looks good. I'm going to press enter. then the calculator tells me to take a guess. So I'm going to go ahead and try to get as close to that point that I'm looking for as possible as my guess. And here we go. It tells us the 0 at that point, or in that boundary, is negative 2.51, since we're rounding to the hundredths place. So my first answer is negative 2.51. Now there's another 0 right here. So I'm just going to repeat that whole process again. I'm going to do second trace. That gives me the calculate menu, and I'm going to choose option 2. All right, the left bound for this point, I need to set like a limit to the left of that point and to the right of that point. So I'm going to move my cursor with that right arrow closer to that point. I technically could set my left bound like right here, right? Because I'm to the left of that point and there's no other 0 that would lie in between. So I actually could go that far left. I just prefer to go a little bit closer. All right, so we have something about there even is fine. And then my right bound, I just need to go to the right of that point. This one right here, I need to go to the right of it. That looks good. And then I'm going to take a guess right about there. And here we go. My 0 is 2.51. That's actually the positive of the last answer that we got. That's a coincidence. That doesn't always happen. Okay, so my answer for the one on the left was negative 2.51 and the one on the right was positive 2.51. So those are our two answers. All right, so again, the most important things are make sure your mode is in radians, make sure that you've set your window using the intervals that you're given, and then make sure that you are plugging in your equation in a way that it's equal to 0. And you don't have to write equals to 0, that's what y implies. Okay, and then from there, once you have those 3 basic settings, from there it's just investigating the graph and using the calculating feature to figure out what those exact zeros are. If you have questions, you can always email.